Okay, I hope everybody can. Am I audible to you all, children? Those are in the online mode. Remember this, we had completed the limits topic in all its perspective. Today, what we are going to do is we are going to do a slight revision of whatever we had done in limits topic. Okay. Now, remember what I expect you to do, and in fact, some queries had come up regarding the sums from the worksheet. The sum, if you are able to do the worksheet, it means you are doing the sums of your textbook only. So don't worry about it. So practice the worksheet, that is more than enough. Okay, because you are indirectly practicing the textbook exercise sums only. Now, what we are going to do today is we are just going to touch all the, and I want your participation in total to understand and make me feel that you know a little bit of limits by telling me what method you are going to adopt while evaluating the limit sums. So this is the way you go, children. So today's lecture will be the final lecture on limits, and might be from next lecture, that is on 2nd onwards, we will be starting with derivatives. Okay. So first question on limits is on display here. Can you take the limit? My first question, can you take the limit? No, because the denominator will become 0. So what is the technique? Our rationalization, because whenever you see roots, you will rationalize. So children, I just give you 2 minutes. Can you rationalize the numerator and try to evaluate the sum? I'm so impressed with you. You are coming regularly to the classes. Okay, good. Yeah, you are once in blue moon, but this season, I think, yes, sir, like a big, there's a big boss room, and you are entering into the big boss room very frequently nowadays. Okay, good. Okay, let's see now. Come on, gentlemen. Next, what is it? Okay, I think I will also share the things with you. I think I have to rationalize this part. So you also do it. Don't copy from the board. Try to do it. So everybody, those who are not there, pay attention now, as I cannot take the limit. I have to rationalize the numerator. So this will become into root of x plus h plus root x. So what happens in the numerator, Ritsika? A plus b, a minus b is a square minus b square. Very good, beta. So what will happen now? Limit of h approaches 0. A square minus b square divided by h into root of x plus h plus root x. So what happens now? This x and x gets cancelled here. This h and h also gets cancelled. Eventually, what is left out is limit of 1 upon root of x plus h plus root x as h approaches 0. So it's a very simple game changer there. Now I have to put h is 0, not x is 0. So h is 0, it is 1 upon root of x plus 0 plus root of x. Answer is 1 upon 2 root x, not 1 upon 2. How many got this right? Very good. Fantastic. Now the next question. Now nobody will tell in the offline mode. Those in the online mode, can you tell me what format it belongs to? What form you can apply? Come on, even though you are wrong, it's okay. You make an effort, children. What are the different techniques in limits you had seen? You had seen factorization, you had seen rationalization, then you have studied limit of x raised to n minus a raised to n upon x minus a is na n minus 1. Children, I really want you to come out of your play area now and start focusing on your studies for the next 2 months. Okay, now I hope everybody knows this form. Everybody knows this form. This is limit of x raised to n minus a raised to n upon x minus a. X minus x approaches a. What is the value of this? Na n minus 1. So this is given to you. By the way, m, they're asking m. So I'll just make this m. Okay, so they're asking you the value of m. So what happens now? This belongs to this category here. So ma m minus 1 is equal to 80. Please factorize this. It will be better option for you. 80, 2 40s are, 2 20s are, 2 10s are, 2 5s are, 5 1s are. Okay. Now you look at this particular pattern of sign, right? 2 raised to 4. So I think I can get this now. So if you look at both the pattern, now m is definitely 5, just for a confirmation there. 2 raised to bases are same here. So can I say 2 raised to m minus 1 is 2 raised to 4. So m minus 1 is equal to 4. M is nothing but equal to 5. Now look, Krish, these sums are really meant for you all. Understand this, how to do it by comparing Now you might say, why you split it up? Because there is no other hope. I know there is a equality between this term and this term. That means this is 2 into something. So I factorized this and I found out 80 is 2 raised to 4 into 5. That's what I wrote. And then what I did, I compared. So from here, m is equal to 5. I got. But I have to confirm that answer by taking this also should satisfy. So 2 raised to m minus 1 is equal to 2 raised to 4. So bases are same, equate the powers. So m is equal to 5. This is one of the very, very good sum which you will not find in your textbook. Keep that in mind. Okay, so this is the beauty of these questions. They have been taken from n varieties of patterns of sums J, which you will really enjoy doing it. Even though you don't get it, still that's not an issue. But this situation is important, which we are not seen anywhere in the near future in the previous topics on maths. So this is what is one of the adjustments you have to keep in mind. I hope you got this point clear. Very beautiful question. Have a look at this question. This sum doesn't come every day. Remember this. Online children, I want your active participation. My offline students are doing well over here. I want you to participate. Question is not whether you say me the right answer, give me the right answer, or do away with the wrong one. What is important is your active participation is important. Just don't sit there and hatch eggs. Okay? Come on, I want you all to participate in 100% Toto. Now, next question goes to all of us. Here are the surprises. Limit existence of limits. Anybody remember the existence of limit? When does limit exist? LHL is equal to, when LHL is equal to RHL is equal to f of a. Then I say the limit exists. Now they are telling us, am I right? No, only LHL is equal to RHL. Now f of a? No, because there is continuity. Okay. Limit exists when left hand limit is equal to right hand limit. Now the question arises in this sum, modulus function I taught you, it is a non-usable function. So how I change this to modulus into usable format? So this is positive of x minus 4, x is greater than or equal to 4, negative x minus 4 when x is less than 4. So instead of using this modulus one, you have to use either one or both based on the left hand limit. Now they are telling us, or man, that prove that this does not exist. That means I have to prove LHL is not equal to RHL. So those who are absent for this pattern, so just listen, I'll explain it as and when possible. So first step is, let us get LHL, left hand limit. Left hand limit ka matlab kya? Limit of the function at 4. So x tends to 4 bar, matlab left of 4. Now left of 4, what the function has to be given something here. In place of the fx, you have to write something. So what I'm going to do is, I'm going to write this out. So limit of x tends to 4 bar less than 4. Which function? Now look, denominator I have no problem, but the numerator has to be written any one of them, right? Because the modulus is in this form. So left of 4, which function, first or second? The second one. So I can say minus of x minus 4 and copy the denominator of the function, original function as it is, right? So what happens over here? Tell me. This cancels, what happens? Minus 1. Similarly, can you calculate RHL, right hand limit? Okay, now hold on. This is not my job. Left hand limit I got. Now similarly, I have to get the right hand limit now. So right hand limit, here you don't have to put 4 minus h in this case. The reason is it can cancel directly. So 1. So I can say here limit of a function at x tends to 4 plus. 4 plus ke liye which function you will take? Greater than 4, the first one. So remember this, those who don't know, please follow it. Limit of, this will become x minus 4 upon x minus 4 as x approaches 4 plus. Cancel, answer is 1. So left hand limit is minus 1, right hand limit is 1. So I believe my conscious there that left hand limit is not equal to right hand limit. Therefore, I proved limit does not exist. Got the point? Generalize the procedure, nothing much, nothing more. The first exercise of your limits topic is based on this concept. If you want, we will do some because some students missed up that explanation. Okay, so as you go on. Okay, the next sum, the deadly sum, trigonometric limits. Now, when I look at the KR, trigonometric limits, first of all, what are the two important results in trigonometric limits which you use? Anybody can tell me in the online mode? Very good, very good. So tan theta upon theta is also equal to 1. Now the question is how I deal with the question. So I can always do in trigonometric limits to the numerator separate, denominator separate. I have to divide and multiply. So what is your choice? What is your choice? What is your choice? Can I do upon 7x multiply by 7x upon 3x multiply by 3x? Why I did this? So that theta comes the same. This is 1. Very good. So 1 into. So this will be limit of x approaches 0. Sin theta upon theta is 1. Sin theta upon theta is 1. So 7x upon 3x. X gets cancelled. Limit of a constant is a constant itself. 7 upon 3. Just have a look at this. How many did this sum on their own? Very good. Come on, try it out. Those who could not do it, trigonometric limit, those who have missed the classes terrifically, I will share the lectures. Just send me a message today. Over the weekend, 100% see it because this topic is not going to be taken back again. This sum is very close to my heart. Anybody can tell me a trigonometric limits, Krish? Any hint you can really share your intelligence with me? How you can do only for this? Where a fraction has full term, either you have to divide by that full term, you can't do individually. If this is also, then you do. You can't do sin x upon x into x. What about this? It is a part of numerator. So you can't do. Okay, give you a hint. You all are struggling with the complexity of trigonometry. I promise you, it's not the case here. Can you divide both the numerator and denominator by x? And see whether, okay, I'm going to do both the ways. I mean to say a simple way. I will divide the new. Now, Krish, what strikes me to do that? If you see there is x over here, you can't, what Krish suggested is, so isko divide by x, multiply by x. So isko to karna padega na, isko bhi karna padega na. So iske liye हमको दोनों तरफ करना पड़ता है. So let us see. Divide the numerator and denominator by x. So what happens? Let us see. Limit of x approaches 0, 4 sin x minus 9x cos x upon x upon the denominator 3x square minus 5 tan x upon x. Now give this x to bloody all of them. Let us see what happens. Limit of x approaches 0, 4 sin x upon x minus 9 cos x, because x upon x gets cancelled, upon 3x minus 5 tan x upon x. See the sum broken down like 9 pins. So now taking the limit 4 into 1, because sin theta upon theta is 1, minus cos 0. Cos 0 is 1. So minus 9 upon 0 minus 5. So 4 minus 9 is minus 5 upon minus 5. Answer is 1. Anybody got this answer right? Barefoot. Hurry up, children. I think you all have to be spoon. If I want to do 1001 sum, after doing the 1000 sum, you will not be able to do the 1001 sum because you want everything to be spoon fitted. Come on, try to just be a little bit excited as you were there in the first term. Hurry up fast. How many understood this sum? Got it. Who will tell me the next question is slightly difficult one? Remember, when power is there, it should be the pattern of that power. But that power pattern cannot be applied here because of some genuine reason. Huh? One term, correct. So what are you going to do? Rationalize. There is no root. Huh? Haath mila. This girl has again, this girl has again showed me that she is above average. That day also what she did, so understand, now when I showed you the formula there, thank you Patange, I told you this x term has to be same, a term has to be same, j. Now in this case, beta, what happens is, power is there, but that doesn't belong to that format because here x is 1 minus x. So any hint, she has given me the hint. What she did? Plus 1 and +1 and -1, Shirin. Okay. +1 and -1. Plus bracket.
X plus 1. Yeah, X plus 1 can be 1 term. But yeah.
Okay. The problem is her adjustment didn't work here because 1 minus x करता है तो हम लोग अगर 1 minus x नहीं होगा ना इधर x 1 minus तो दो हाँ माइनस नहीं होगा ना नहीं होगा so hold on but this adjustment is pretty good you can do it but it will a little bit add complication अच्छा एक काम करो मुझे can I say 1 minus x as a just for my convenience ठीक है कर दो if I put 1 minus x as a तो यहाँ पे लिखते क्या होता है देखो so this will become a raised to n minus 1 raised to n as it is upon this x. What will be x from here?
1 minus x is 1 minus a.
1 minus a. Am I right? And यहाँ पे limit क्या होगा? If x becomes 0, what a will become? ठीक है? अब इधर a n minus 1 raised to n. Can I do ulta? So limit of a tends to 1. I can write a raised to n minus 1 raised to n of minus of a minus 1. So this minus go up outside. So it looks the same pattern. A raised to n minus 1 raised to n upon a minus 1. So I can apply that formula. Na minus of Na n minus 1. So any number 1 raised to n number is 1. So answer is minus n.
So why did you take denominator 1 minus 1?
Because why did you get?
Second वाले step में 1 minus a कहाँ से आ गया?
Because denominator sum में क्या x है? Look at the substitution.
1 minus x.
तो x को उधर चला गया तो a क्या हो गया? x का वैल्यू क्या है? 1 minus a हो गया ना? Now this adjustment is very rare. Don't get scared. Okay? Hurry up fast, Mr. Footballer. सच्चाई चुप नहीं सकती. बदमाश. Hurry up.
Sir, 1 raised to n minus 1. How have you taken it as 1 minus n? 1 raised to n minus 1.
1 raised to any number is 1. You put any number.
It's 3 raised to minus 3 minus 3 minus 2.
अबे 1 raised to any damn number is 1. Correct ने? पता है कि that adjustment I think थोड़ा लेकिन कर सकते वो भी है वो भी कर सकते उसको उल्टा करके ऐसे होगा आंसर लेकिन थोड़ा सर फट जाएगा उसका ठीक है but anyway thank you very much for your suggestion. How many got this party? See 2 by 2. Arif क्या नाम है तेरा यार? Ariz ना? हाँ. So I hope you got this point. See, every sum is unique today. Don't get in a sleepy mode. 31st सोना चालू करेगा तो अगले साल पूरा साल सोते रहेगा. तो क्या? And what is your tiredness, brother? You tell me.
So we woke up, we came from turf.
That is tiredness. That is tiredness.
Yes.
Damn it, man. How many got this point clear? Huh?
अब बोलो ना अभी इसका नहीं था ये रात को स्कूल में दिन बजा.
Let's take the next question. This now this part I know you will not be able to do. If you remember mathematical induction, don't remember so much. Just remember something out of it. There was a proof of 1 dot 2 dot sum of sequence of n natural numbers is always n into n plus 1 upon 2.
Yes.
So in place of this, you have to write this. Now you must say, ये तुमको सपने में आया था क्या? सपने में नहीं आया था. These are very basic sequences whose sum you should know in n format. So sum of n natural numbers is given by the formula n into n plus 1 upon 2. So I'll just put it over here. So limit of n approaches infinity. So in place of this, I can write n into n plus 1 upon this 2 will come in the denominator. It will look like this. Hello? 1 by 2 outside. Does this belong to a normal limit sum? What type it is? N tends to infinity. N tends to infinity. Yaad hai wo din? So whenever n tends to infinity, what is the procedure? Go back. You find the highest power of x. So here it is case of n. What is the highest power of n? 2. So divide the numerator and denominator by that bloody n square. You all don't know. Relax.
N square plus n.
What?
N square plus n.
अच्छा ठीक है कुछ फर्क पड़ा तेरी जिंदगी में नहीं समझ में आया so let's see so what will happen now divide the numerator and denominator by n square. Why I'm doing by n square? Why not by n cube? Whenever n is approaching infinity, you find the highest power of x or n in the particular sum. Remember n tends to infinity का हमने sum किया था काफी. So अरे याद है क्या? Right. So divide the numerator by n square. So what will happen now? Half limit of n square plus n upon n square upon n square as n approaches infinity. Now if I give to all of them, this will be half limit of 1 plus 1 upon n upon 1 as n approaches infinity. Can you remember one result here? Limit of 1 upon x as x approaches infinity is what? 0. So tell me 1 upon n will be 0. So 1 plus 0 upon 1. What is the answer? 1 by 2 into 1. Answer is 1 by 2. Children, every sum is unique. Don't just sit and warm the benches here. Value the time you are spending in coming here and going home and the time you are spending here. Value your time. Then you will pay attention. Next question. Can anybody tell me what form it is? Second type. Second type. What is the second type, guys? The second type was limit of x raised to m minus a raised to m upon x raised to n minus a raised to n x approaches a is given by the formula m upon n a raised to m minus n. Apply this formula and do it. So by the way, Arman, I think you look partially, you don't look fully, always. So this I can write 1 as 1 by 3, this is 1 by 6. Then it will be on to this form. Hurry up, Arman, and show that you are Spider-Man. Hurry up first. Kia. Try करने का try very short, not shorter than you. Hurry up fast. What's the formula? M upon n. अरे समझ में आ रहा है क्या बच्चे लोग? So this will become m upon n, 1 upon 3 upon 1 upon 6, 1 raised to 1 upon 3 minus 1 upon 6. Right? This is 1 only, so answer is 2. Got the message clear?
Yes.
Children understood? The next two sums are surprise sums, good sums, and you have to do on your own. Are you all ready? Parents, next. Yeah. Trigonometric limits, Mansha. Come on, Auri. Look at this. 1 minus cos. Sorry. I have not given the sum wrong. I have the formula for 1 minus cos 2x and 1 minus cos x. एक काम करो इसको उल्टा कर दो और फिर तुम उल्टा हो जाओ काम खत्म. Hurry up, let us feel the heat of this question. I want to remind you about this formula. What is 1 minus cos 2x? What is 1 minus cos x? इसको उल्टा कर दो दोनों उल्टा खत्म. Try it out and tell me what is the answer for this sum. Come on, those who are absentees, I'm sorry, these footballers. Okay, I think how many got the answer? Let me do it. Limit of, I can write this. The sign will nullify this, you know. So square आया तो डरने का नहीं. I told you in trigonometry if square comes, वो full trigonometry raised to square लिख देने का, so it becomes easier for us to handle. So for example here, this will become 2 sine square x upon 2 sine square x by 2 as x approaches 0. Now just a minute, 2 can cancel. So this I can say as limit of sine x by 2 whole square, sorry, sine x whole square upon sine x by 2 whole square. Now what I can do? I can divide by x, multiply by x square. Divide by x by 2, multiply by 4. Now here, don't cut now till you write this. 1, 1. Answer is 4. The next sum is very close to my heart. Can you apply the standard trigonometric things to do in this sum? Can you tell me why? Arman, haath mila. Yes, whatever. Okay, now hold on. There is a very strong problem in this question. I'll tell you why. अगर 90, 360, 180, 270 होता था तो 90 minus theta, 360 and all those things can work out. लेकिन ये है I don't know, Baba. Okay, there is no other option but to do that. He says let x be equals to pi by 6 minus h. Okay, because x is not tending to 0. Relax. अरे हीरो पानी पी रहा है क्या दुनिया का समुद्र पी रहा है एक साथ. Okay, no problem. राम तेरी गंगा मैली. ना इधर देख, समझ में आया? What is the name? What is the name? What is the name? Useless fellow you are. Haitali ना क्या नाम है तेरा? Haitali. Okay, इधर देख रहे महाकाली इधर देख. Hey, no. Now x equal to pi by 6 minus. ये √3 इधर है. These are very rare समा. लेकिन आया आज मेरे को अच्छा लगा. √3 है. Now problem के अंदर का pattern I am not worried. This √3 is a problem because it is going to stick with sign everywhere. It's not possible to extract that. So just see √3 upon 2 and 1 upon 2. याद है आपको? √3 upon 2, 1 upon 2 are the standard angles. Sine 30, sine 60. So what I will do is I will think something like this. I will talk about this later on. First, let me just do what I did. I divided the numerator and denominator by 2. Now you may say, Q, have you gone mad? Yes, sometimes. This 2, I'm writing this properly. Now look. Okay, now this 2 will go up, so I'm not worried. 2, okay. Limit of x tends to pi by 6. Hold on, guys. This is √3 by 2 sine x minus 1 by 2 cos x. And this is same thing, x minus pi by 6. Upon 2 I taken up here. This goes up here. Okay. Now hold on. Now if you look, what is √3 by 2? Sine 60. Sine 60. And this is sine 30. I said cos 30 sine x minus sine 30 cos x upon what? X minus pi by 6. Correct? Now do you remember this? Sine A cos B minus cos A sine B. This is sine of A minus B. So 2 limit of x approaches pi by 6, this is sine of A minus B upon x minus pi by 6. Remember, sine A cos B minus cos A sine B is sine of A minus B. Now, what is A? X. And what is B? 30. I wrote pi by 6. Now, this is my theta. Sine theta upon theta is what? 1. Now, I can change it. X tends to pi by 6 plus h. Now, it's better. Okay? Pi by 6 plus h. So, let us do it. So, x, instead of this, oh, you can do it here because I have to put across that point. I'll say x minus pi by 6 bh. Now, what happened? Just see 2 into limit of, this is x minus pi by 0, sine h upon h as h approaches 0. What is limit of sine theta upon theta? 1. So, 1 into 2. Take down this sum. तो यहाँ पे लिख लो, this is sine of A minus B is sine A cos B minus cos A sine B. I applied the formula here. Come on, hurry up. This is one of the deadliest sum which you saw today. One of the deadliest. It's really good sum. It's not easy. Only because there's root 3 there's a problem. Otherwise, you can directly use the formula for sine C minus sine D in the numerator itself. Right up. Hurry up fast. Okay, next question I want to do. I'm going to do the next two questions now. Look at the sum. They are asking us find the value of k if this is equal to this. So, ये तो function when x tends to pi by 2 is this function, and f of pi by 2 x के बदले pi by 2 है तो what is the value? 3. इसका मतलब when x is equal to pi by 2, when x is equal to pi by 2, the function is 3. When x is not equal to pi by 2, got the point? Now see what I am going to do. So limit of x tends to pi by 2, matlab not pi by 2, only tending to pi by 2. So which function you will take the first one? K cos x upon pi minus 2x, okay, is equal to f of pi by 2. Matlab jab x, see this x has been replaced by pi by 2. So when x is pi by 2, what is the function? 3. So equals to 3. Now you forget everything, solve this. Now trigonometric limits mein x tends to a is not allowed. So what I will do? X equals to pi by 2 minus h. आपको याद है? अरे ये सम किया था ना pattern. X tends to a होगा तो this method you have to adopt. There is no other option. You are absent. So x equals to pi by 2 minus h. Put it over here. So limit of k into cos of pi by 2 minus h upon pi minus twice of pi by 2 minus h is equal to 3. Now limit will change now because there is h everywhere. X is tending to pi by 2. So look at the substitution. If x becomes pi by 2, h will become 0. देखो ना, pi by 2 आगे तो cancel हो जाएगा ना, h will become 0. खत्म. Now k is a number. I can take it k up outside. This will become limit of h approaches 0. Cos 90 minus theta is sine theta. Pi minus 2 into pi by 2. Pi gets cancelled. And 2h is equal to 3.
Right. No, x tends to pi by 2 means it's not equal. That's why you're using the first.
Huh?
X tends to pi by 2. It's still a
huh. Now, this 2 can come out. What is sin h upon h? So 2 is outside. So what is left out? K upon 2 is equal to 3. K is equal to 6. The next question. Are you going to test the final assault? The next question. Rationalize karo numerator ko. Limit of x approaches to x square minus 4 upon 3x minus 2 minus into 3x minus 2 plus x plus 2, 3x minus 2 plus x plus 2. Now look at the denominator. A minus b, a plus b is a square minus b square. Wait now. A square minus b square. A square minus b square. This will be as it is. This I can say x minus 2 into x plus 2 into this as it is. 3x minus 2 plus x plus 2. Now what happens to the denominator? Limit of x approaches to x minus 2, x plus 2, root of 3x minus 2, x plus 2 upon, now look, 2x minus 4. So can I write twice of x minus 2? This x minus 2 gets cancelled. I can directly take the limit now because denominator is a non-zero number. So if denominator non-zero, 2 plus 2, 4. This is 6 minus 2, 4. That is 2 plus, this is 2 upon 2. How much it is? Do you get the message and pattern clear? This is much easier. So, you see, what you have to understand is how to do. Solving slowly, it will get, after final exam, you will become pakka. Okay? Now, I hope you got this point here. Today's sums were all exclusive questions. Remember this. So, that's all for today. Thank you very much. Bye-bye 2022. Welcome 2023. And a very, very happy new year to all of you. So, thank you very much. And God bless you all. In case anybody wants a specific lecture of limits, message me through your personal chat. I will send you the link to you all. Okay? Thank you once again and bye-bye.